Certainly want to say how much we appreciate each of your presentation and all the work that has gone into it and all of the time pressure, but I think everybody here can appreciate that we are, in fact, getting whatever the state-of-the-art data there will be, and that will serve the committee well. We now have a good half hour for questions from the committee and comments, and I really urge the committee to think about that. We've got 25 minutes anyway. And while you're getting ready, I mean, there were a number of things, like you said, that I think were very unexpected. And it's wonderful to have data. And I think one of the things that I really will be taking home is about the intake, particularly of sodium, and how we start to frame this as sort of purchase prepared foods, as opposed to what we used to think of as commercially prepared foods that we mostly brought into our homes. I know I've spent many times talking about, how much sodium is in the tomato sauce and all those other things. But a real part of this is capturing now the change of how much of our food comes from restaurants. So it's not just what we buy at the grocery store that's pre-prepared, but those other sources. And it really does go back to the challenge of how are we going to update our databases, and how can we build relationships with restaurants and with recipes and that sort of thing, so that this can get better. So I'll throw that out there as a start, and others will have more questions. But going forward, and even in the committee deliberations, this seems like sort of a game changer. I used to blame everybody's added salt at the table. Clearly I'm wrong, right? So. It's the little middle button there.
It's on. It's on? Oh, okay, good. Okay. So in terms of the amount of sodium
pull it a little bit closer.
Oh, okay. Oh, now it's working. Okay. The amount of sodium consumed at restaurants, I might not be remembering this right, but it's about 25%, or it may be more, of our sodium is consumed from restaurant foods. And in terms of the data for updating data from restaurants, the nutrient analysis program of USDA also collects restaurant foods. That's one of the things they do, is laboratory analysis of restaurant foods. And we have worked with New York City to fund MenuStat, which also includes brand-specific information on nutrient values for restaurant foods. So I know USDA is aware of this. They're trying to include brand-specific information on restaurant foods as well. And maybe, David, I don't know if you want to add anything to that, or.
That'd be fine. Please.
The branded foods database has increased our numbers from about 2,000 foods 2 years ago to 250,000 foods. Unfortunately, most of that includes only what's mandated by FDA on the food label. So certainly for older foods, we don't have potassium, but a few manufacturers have submitted additional information. The majority of the restaurant foods we have are from large chains that have 20 or more locations. And we have a very limited number of samples from individual restaurants, and those display extreme variability in sodium content.
Okay. So, if no other comments, I'd open to the committee.
I had just a brief clarification. It seems clear that sodium and calories are highly correlated. I was a little bit unclear on the potassium, because Dr. Coswell, your graph seemed to show that, in those distributions, that there's still that gap between males and females that just visually didn't look that different than the gap for sodium.
So the correlations with calories, with sodium and potassium in urinary excretion, or sodium and potassium with dietary intake.
With dietary caloric intake.
So
right.
calories, calorie adjusted.
Yeah, calorie adjusted.
Yeah, I'll just quickly say I think the correlations are around 75 or 80% for potassium with energy intake. Do you want to?
Yeah, so we can give you tables for the potassium density as well. We have draft tables, but our protocol is that they need to be replicated independently by another analyst. So if you would like potassium density tables, we can do that as well. The potassium density does explain much of the difference. I can tell you from what I've seen. But in potassium intake, but not as much as sodium, not quite as much as sodium.
Next question, please.
Hey, I was struck by the potassium urinary excretion being lower in NHANES, but I was kind of surprised because in Dr. Lurie's presentation, you said that from the pooling project data, Friedman et al., that the bias was 0 to 4% for 24-hour recalls for potassium. So I was just wondering if you could comment on the difference.
Okay, so one of the things Friedman did is they adjusted their dietary intake estimates for the amount consumed. Let's see if I'm saying this right. For the amount consumed that is excreted, and so what you saw from mine were unadjusted estimates. This is just what the dietary intake is. This is what the 24-hour urinary sodium excretion, urinary potassium excretion is. So in the Friedman study, what they did was they adjusted those estimates for the amount of potassium excreted in urine. So they're going to be inflated or more like what they might be. So they did it based on past studies, basically.
So they just kind of divided by a factor or assumed certain percent is excreted?
Yeah.
Okay.
Yeah.
Right. And I think you could correct me, but I think that the potassium, the urinary potassium was about 10%. No, maybe it wasn't. It was much larger than that. Yeah. Okay. So anyway, I think that it is the calibration that they did.
Next question.
When you presented the distributions of sodium, particularly the percentiles, was there any attempt made to correct for the measurement error in those?
Yes. So I should have said that at the beginning, and I was going too fast, so I didn't. But so the estimates that are presented there are usual intake estimates, and they're based on the NCI method, or the National Cancer Institute method, using up to 2 24-hour dietary recalls and adjusting for within-person day-to-day variability in intake.
Other questions? From the committee? Mm-hmm. Please. No, keep going. This is our time. You keep a microphone for a while.
Okay, Dr. Endergay, I don't know. You talked about the effects of sodium and potassium on blood pressure and vascular stiffness. Are there any other effects, physical effects, that would affect cardiovascular disease, like left ventricular mass or something else that would impact, that could not be measured with blood pressure?
Sure.
There we go.
The last slide, I listed, I believe, between 15 and 20 different healthy effects of a high potassium diet in comparison to a low potassium diet on animals on the same sodium intake. So these were comparisons. There was a comparison for a given salt intake, and what happened is that some of them are, for example, on the cardiovascular is baroreceptor sensitivity. There are some that are much more involved to measure. So some of them were basically findings on experimental studies in animals that with the limitation we have about human studies, cannot be replicated. Maybe 50 or 60 years ago, probably was legal to do. So what I'm saying is, unfortunately, a large fraction of the data is physiological data on animals, and but certainly it was not mentioned before, but the incidence of strokes. Strokes, as you know, the so-called stroke belt in America, including the Louisiana area, etc., this has been clearly related to relatively low potassium intake. So in some areas of Japan, for example, there is no question that there is quite a bit of studies showing cerebrovascular disease related to high sodium and relatively low potassium. Lou Tobian, a very distinguished investigator from Minnesota, now is deceased, has done tremendous studies showing that high potassium on animals, on rats, on a high sodium intake, sometimes the protection on the kidney function, the protection on strokes was present despite very mild or no effect on blood pressure. So the point being that there is a tendency to think that the problem is the blood pressure. The blood pressure, to a great extent, increases because of changes that occur in different parts of the body, and diseases and defects are occurring in association with hypertension. So, not blood pressure is relatively easier, if you will, quotation marks, to handle, in the sense that you can do in a non-invasive way. But there are many other things that are occurring.
Just one comment. So, several studies, if you control for blood pressure, sodium still has some effect on vascular, and that might possibly explain that. Right. I have another question. Is sodium potassium related to inflammation?
Yes, it does. Absolutely, it does. There is quite a bit of evidence of cytokines stimulation and tissue damage related to low potassium. And I just want to bring a point about sodium potassium in humans as compared to animals. In every single animal that I'm aware of, if you start changing the diet of the animal and you put on a high salt intake, you develop hypertension. So it's not just so in sheep, in many other animals, it's the same thing. Chimpanzees, whatever animal you think, if these have been studied, it shows that high salt produces hypertension, and potassium tend to have the inverse effect. Not only that, those animals are typically vegetarian. They are basically eating what prehistoric humans or isolated populations eating non-processed foods were eaten. That's why they didn't have hypertension, and we do have.
We have one of our committee members isn't here in person, but listening in and sent in a question. So, Megan.
Would you please provide summary impressions of the sodium to potassium ratio after the data from Korea? Please comment on this differences captured by 24-hour urine for sodium and potassium. Would you recommend we consider we consider as we look at the data on
Well, I think it's I don't know what to say really. I think it's very difficult because if you're looking at if you're looking at your urine, the potassium may be off by as much as 50%. It's probably off by less in general, but it really just depends on the population of the study, the composition. There is some difference. There is some. It appears some difference by race. So I think if the population is largely white, that's what the studies have shown. It may be a little bit better, but even those small balance studies that were done in the 80s and early 90s were largely white populations, and they showed that it was not a high percentage that was recovered in the urine. So I'd just be very wary of urinary potassium for both, in and of itself and for the ratio. And even with dietary, the ratio of sodium to potassium, I think there's much more of a problem probably for sodium, maybe less for potassium. So I think it's really tough. Unfortunately, that's the way it is.
I would just like to reiterate what Dr. Apple said earlier, that when you're looking at the ratio, probably the best type of evidence would be from trials or feeding studies where you're giving people different levels of potassium and different levels of sodium. We don't have much of that, but that really is the best evidence.
Can I? So, Dr. Andraghi, I take your point that the kind of physiological mechanistic studies in animals can't be done in humans. But I'm wondering if anything, you showed data on effects of high sodium, low potassium on angiotensin or aldosterone. Have any of those effects been looked at in humans?
I just want to bring the point about aldosterone and the aldosterone levels of individuals eating natural foods are higher than many patients with primary aldosteronism. So what I'm trying to say is this: serum aldosterone, in fact, if you give DOCA or aldosterone to individuals or animals, they are on a low salt diet, nothing happens. So everything happens if you give mineralocorticoids or aldosterone with a high salt intake. So there have been never a study demonstrated that you can induce mineralocorticoid excess hypertension if you have on a low salt diet. So if you will, the point being, or centers, and what is the typical body composition in high aldosterone, on high renin-angiotensin aldosterone situations? Well, you may have some increase in exchangeable sodium. You have definitely a decrease in total body potassium measured with natural potassium and natural radioactive potassium, or K42. So the point being that the biggest association are with a low tissue potassium and high sodium.
Thank you. We go.
Dr. Loria, I wonder if you could elaborate a bit on your slides related to how the errors, systematic or random, can change the either attenuate or otherwise change the effect, the reported effect. Particularly in the case of pairs of RCTs, the behavioral intervention studies, whether there's any evidence or potential differential bias that you mentioned as a potential issue. And then second, on the individual level, whether the crossover trials might have some limitations, due to, again, the errors related on the individual level being
greater than all the
Okay, so I'm not sure I quite got this, but so you were talking, the first one, which slide were you talking about?
The one that says limitations may differ by group versus individual.
Right. So the differential bias in between treatment arms in a randomized trial. So I think we don't know. I think you have to be aware of the fact that there may be differential bias, and usually in those behavioral intervention trials, the most frequently used instrument to measure diet is a food record. And so because of that, we know, I think from some of the NCI studies, that there is some reactivity. There is more error in a food record based on reactivity. So to whatever it is. So you're supposed to be consuming a certain diet, you're more likely to report that. Sometimes in a 24-hour recall, there's a little bit less of that reactivity because you're just asking people to report the previous day, and they're not so focused on reporting as they go. So what was your second question?
You said that on the individual level, so this is your second bullet, so that single day leads to random error, and whether in crossovers with individuals or certainly controls, whether that there might be more potential error, or just comment on the errors.
So the crossovers are usually randomized trials, though, right? Is that what you mean by crossover? So in that second set of bullets, I was talking about mostly the cohort studies where you're doing the individual level analysis. So I'm not sure I understand your question, I guess.
I guess just again, in the crossover, it's like behavioral, and they could have the same issues.
That's true if you're not using urinary sodium as your measure. Yes.
Thank you. If there are no other questions, I'd like to thank this panel and we have another question. Sorry, please. And right after that, no.
We did not do the bivariate method, and I know that could affect the results slightly. So I'm not sure if that's actually in the footnotes or not of the tables that was presented to you. The bivariate method is even slightly more complicated. So what we did is we just took the ratio for each individual and then did the usual intake estimation.
Okay, that's what I got from the footnote, but I just...
Okay, thanks.
Very good. So thanks to all of you. Thanks to the whole morning panel. I think it's been an extraordinary session.